For years, astronomers have been on the hunt for the first generation of stars, primordial relics of the early universe. Now they may have found them. Visbal from the University of Toledo, Ohio, and colleagues believe they've glimpsed so-called population 3 stars following an analysis of observations by the James Webb Space Telescope of a distant galaxy called LAP-1b. Population 3 stars are thought to be composed entirely of hydrogen and helium with traces of lithium, the ingredients left over after the Big Bang. They formed early on, around 200 million years after the start of the universe. These stars are extremely rare because they died out long ago, although scientists have always hoped that the faint light from these distant ancient objects would be detectable. Previous population 3 candidates have been ruled out because they didn't meet the 3 main predictions about their formation and properties. That is, they were formed in small dark matter clumps, known as halos, were extremely massive, and formed in small clusters. In their paper, published in the Astrophysical journal Letters, the team believes their discovery satisfies all 3 requirements. First, the population 3 stellar system formed in the exact environment scientists predicted, namely a dark matter clump around 50 million times the Sun's mass. Another reason is that the stars are massive, ranging from 10 to 1,000 times the mass of our Sun. These huge stars clustered together, but only in small groups totaling a few thousand solar masses, confirming the third prediction. Further evidence comes from the gas surrounding LAP-1b, which shows distinct spectral signatures and contains only trace amounts of metals. This is consistent with a scenario where the system is so young that some of the first massive stars had recently died out, exploding as supernovae and polluting the gas with these early elements. While this research is exciting, it's not yet final confirmation of the discovery of population 3 stars. Some uncertainties remain, such as exactly how much material the first supernovae ejected, and whether current computer models capture the physics of the early universe. But while we're waiting for that confirmation, this new study can provide a roadmap for finding other distant objects, such as combining the power of the Webb Space Telescope with techniques like gravitational lensing. This approach, which enables the detection of LAP-1b, means this discovery could be just the beginning. LAP-1b may represent only the tip of the iceberg in terms of the study of population 3 stars with gravitational lensing from galaxy clusters.